Alright, what's up guys? So we're back again with another IV/algae stream. Um, Today's probably going to be a pretty short one. We're just going to try to get through the rest of the scanning thing. Okay. So as you can see, I've actually pulled it up today in Emacs, not just on GitHub. So let's go ahead and pull these up side by side. And let's get into it. So I do remember I need to go over to scan. And let's see. I think we need to start back at operator. Scroll. Oh, I forgot to put this on all of my tags. There we go. Okay, so now I should be able to see at least if people are in the chat. Okay. So let's kind of remind ourselves a little bit. So we're in this this Lex run thing, which is the analog to the state stuff. So it was kind of hard. Well, as far as I'm aware, it was impossible for us to make this definition, this circular type alias, or cyclical, I guess maybe is a better way to put it. So what we did instead was create an enum that we called Lex, and then we have some methods on Lex, but the main one, of course, is run. So whenever they're calling this state function, we're going to be calling our run method, and it always returns, just like their state method returns a new state, our Lex run returns a new Lex that we can call Lex.run on again. So all we really need to do is go through this match and handle each of these variants of our enum. So I think what I did last time, we can just collapse some of this stuff to make it a little easier to look at. And I guess we'll start off with lexing a comment. Whoops. I often hit CC instead of Shift-C to change the rest of the line. So it looks like we're going to loop here, loop. Okay, so we're going to call L.next. That's going to give us a token, it looks like. Token. If we have some time, I would also kind of like to write some tests. Now, these aren't really going to be tests in a proper sense, because I don't think we're really going to be able to test correctness yet. Well, maybe we can. Maybe. we can at least write regression tests. So whatever comes out is what happens over each time. I'm not sure what the correct answer is necessarily yet, but I would like to be able to call our scanner on, you know, like 2 + 2 or something, and just see what comes out. So I think, let's just take a look back here. Scanner, so we've got scanner new, and then let's try to, oh man. Sometimes it does that. Oh, I think projectile is probably not loaded. Projectile. This you. Okay, there we go. Yeah, for some reason it often does that. Let's go back to their main. No, ivy.go. We go down here. So what do we do with the scanner? Run parser. Parser includes a scanner. Okay, so maybe we're going to have to do what I was talking about with the tests on after we handle the parser. Okay, well that's okay. Anyway, let's get back to our Lex comment. So we're in a loop. We're going to call L.next. Okay. I thought this was supposed to return an option. Token. And they're just comparing it to EOF. This doesn't look right. L is a scanner. R is L.next. It gives us the next token. Yeah, this doesn't look right at all. Next. Oh. Wait, what is this? What is L? L's a scanner. RL's a scanner. Uh-oh. Uh-oh. It seems I've made some kind of mistake here. Is this the right directory? Scan. What is this? Oh, this is the lowercase. I'm supposed to call next inner. Whoops. Okay. Yes. Goodness, I forgot. Yeah, maybe we should call that something else. It's kind of confusing. Anyway. Yeah. Last rune, last width. This still doesn't look right. Oh, I just forgot to like set this stuff. Self.pause. Yeah, whoops. Read rune. These are two options, right? Wow. Okay. Last char equals C. Self.last width equals W. Okay. Well, I'm glad we did that. Can I do that? Oh, maybe I can do this. Does that work? Yes. Okay, so maybe I overcomplicated this a little bit. Okay. Great. Oh. That's kind of weird. Maybe I liked it better the other way, but I guess it's fine. Okay. So I also found out something about the formatter not popping up a window. Let's see if we can fix that. Rust. Yeah, format, show buffer, nil. Let's give that a shot. Okay, great. I'm going to add that to my config because I don't really like it popping up a new buffer. So let's go back in here. Now we know that we're supposed to call next inner. Okay. Let's go back to Lex comment. This is probably a topic for another video, but now that eglot, the language or the LSP client has been merged into Emacs, the Emacs master branch, I would really like to switch to eglot instead of LSP mode. I like LSP mode, and I migrated to eglot briefly and then came back to LSP mode because I just found it impossible to configure the language server through eglot. So at some point I'll be tackling that again, and I'll probably make a video about it if I get it to work. But the other thing I like about LSP mode is this breadcrumb thing. I mean, this is pretty cool. And I saw some stuff on the mailing list about how we might be able to get something like that. So stay tuned for that. So if it's EOF, so we're using, I think none indicates EOF, right? Yeah, none indicates EOF. So if it's let R equal this, can we break? Can you do that in a let else? Doesn't look like it. Oh, maybe we can. If R equals new line, also break. Okay, does that work? So that's our loop. So this basically says when our state is comment, so we're inside of a comment, yeah, and the comment marker's already been consumed, we just continue until we hit the end of the file or the end of the line. What's wrong with this? Expected option you made. Oh. How do I forget that every time? Break. Okay, so we just consume until that, and now we check if l.input.length greater than 0. L.pause equals l.input whoops, dot length. And we return l.emit new line. Else return any self any. And we don't need that return. Okay, great. Yep, not is empty. Perfect. And just to be a little more specific, one of the configurations I wanted to make for eaglot was setting my cargo check command to Clippy. I think that's actually why I went back. I had a minor annoyance with some proc macro issues with eaglot, but I think the main thing is I wanted to configure it to use Clippy instead of just cargo check. So if you know how to do that, please let me know. I was reading the info manual today, and I think I'll be able to figure it out, but if somebody else has it already working, I'd be happy with that. All right, anyway, again, back to this. We've got our comments handled. We already handled Lex any. Okay, so on to, let's look for Lex operator. So this completes scanning an operator. We've already accepted the plus or whatever. There may be a reduction or inner or outer product. So basically we're looking for compound operators. Might be an inner product or reduction, but only if it is a binary operator. Okay, so now we got a block for operators. And of course we can factor these out into their own methods or functions at our leisure. Let's see. So the first thing we're going to do, let word equal l.input from l.start to l.pause. And we don't do that. We do that. Let's see what we return at the end, just to go ahead. We're going to, don't need return. We can just say l.emit type operator. Great. So that should take care of that. Consider borrowing here, of course. So this might actually be a little useful helper method. Let's see. Let's look for this. So we got input dot start dot pause. How many times have we done that? I guess I need to put some slashes in here. So we're looking for this, this. What the heck? Apparently we've never done this before. I guess we'll just use grab. So we're looking for grab. Well, let's just look for this. Something followed by dot start, followed by 2 dots, followed by something, followed by dot pause. And whoa. Scan. What? Oh, it must be using the square brackets. There we go. N R. We'll take out the file. Okay. So it looks like we've done it. You see, 3 times. So yeah, we can write a little method for that, right? Do we always call it word too? Text, word, whatever. Yeah, that seems like a good thing to do. We'll just call it word. We could probably call it like, does this one need to be mute? I don't think so. So we'll just return a reference to self-input, self.start to self.pause. There we go. Okay, 192. We used to use it on 192, but we just moved it down. And where do we use text? Self.word. Okay. Maybe we might even be able to inline it. Let's see. Great. 432. Oh. Word. What? Oh. L.word in this case. And then 450, which is where we're writing right now. L.word. Okay, great. Return the current word and self. Input? Something like that. And yes, there is still one because we actually use that in our implementation. Okay, so that's the current word. Probably should be called current word, but I'll just call it word. Okay. Let's jump back up. Likes operator. Things get so wide when you have when you have the font so large. Okay, so let word be L.word. If word is O or binary, whoops. So basically binary built in. Let's go look at this. Plus. Basically is binary. Let's just have a function here. Is binary that takes a string and returns a bool. Because if we remember what this is, binary ops, it's a map of string to binary op, and they were actually the built-in operations because, yeah, you say ops, put all of these ops into binary ops. So all we're really checking in our case is binary built-in from stir s is okay. Yeah. Return whether or not s is a binary built-in. Okay. Or is binary op word or l.context.user-defined word true. Makes sense. So is it part of an outer product? Is it a binary op? Or is it a user-defined word? Now we need to call l.peak, which gives us an option. What do we do if it's EOF? Nothing. We're only looking for it to be a few things. If let's p also going to check if it's an identifier. If is identifier. Oh, there's that again. L.input, L start, L pause. L.word. Wait, what? Why do we do this again? L input, L start, L pause. Oh, they do it again. Well, Wait, isn't this just word? L dot input. Ooh, we're not modifying it anywhere, are we? Because peak shouldn't. Well, I mean, if it's really peaking, it shouldn't do anything. So none of these. Do these all return? Oh, they don't all return. Okay. This doesn't return. This doesn't return. This doesn't return. Okay, I see. That's why this is separate. Okay, I understand. So if it's sum, I guess we can use a match here, right? Match P. The default is to just do nothing. Now if we hit /, we're going to call it L.next. And throw it away. Really? But this gives us a token, right? Switch. It's a reduction. Why would we do this? L.next. Oh, this must just, it advances. Oh, it sets the token. Okay, that's fine, I guess. Okay, in our case we do B of this. We also call next. If we hit a period, that means we're in an inner or outer product. Okay, let's add some comments here. So this is a reduction or scan. This means that we are in inner or outer product. Maybe. We're going to call L.next. It is digit L.peak. Okay, hold on. If let sum p, I'll call it pp, I guess. L.peak. I wish you could put and here, right? And pp. Maybe you can. Was I trying to do something different before? Is digit pp. Then we have to back up and return. Yeah, let expressions in this position are unstable. Can I highlight that? Oh, yeah, that's what I thought. Do we want to use an unstable feature? I kind of do. I kind of do want to do that. Let's take a look at that. Yeah, stream profile. What do they call it? Let chains rest. Let's just take a quick look at the issue. Chaining. Yeah, I mean this would be really nice here. Motivation. Yeah, rightward drift, of course, very annoying. Matching a tuple. Break? Yeah, of course. Yeah, so this would help us with this. Like, obviously we're drifting right because we're inside of this big match. So, as I was saying, if we define the bodies of each of these match arms as their own little methods, then that helps us out there. Okay, that's not really a solution, right? Duplicating code. Yeah. Yeah, I think they do have... There's another like labeled break thing right now. Closer to the middle. Mental model. Okay, let's take a look at the issue. Why are there two? If and while that... For the immediate changes. Take two. Oh, goodness. Kind of confused. So I think this is the main one. Let's just go to the bottom, see what's new. Oh, 2 days ago. Add active tasks. It won't stabilize. Okay, it sounds like it's very close to stabilization. Let's go for it. Yeah. Alright. Lib. Feature. I just need to add another feature, right? Feature let chains. Okay. Does it work now? Excellent. Now it just doesn't work because we don't know what this is. Okay, great. Is digit l.peak. So we have to check if it's some l.peak. I mean, I guess we could let is digit take an option, and if it's none, then obviously it's not true, but I think this is fine. Okay, that's actually done there. If it is some, and it's a digit, it's actually a number, so we need to back up. Okay. Otherwise, we let prev pause equal l.pause. Let rb l.next. I am live, right? Okay, good. Good stream health. Okay. I've watched some snippets of these videos back, and the quality looks okay, so hopefully this warning isn't really affecting the watchability. Oh, whoops. 1 and 2. Okay, there we go. So we're down here. Case. Okay, call l.next. Switch. Yeah, this is always fun, right? Just a naked switch. If L dot is operator R or R L dot is alphanumeric R, and of course we're going to gate these the same way we did before. If let sum R equals R. If let sum, what's the problem here? Oh. If let sum R equals R. What's the difference between what I just did and this? Only supported directly in conditions. Wait, isn't that what I'm doing? If let sum R in 1, does that help? For some reason this doesn't seem to be working. Let's just generate this. Now is he going to be upset? No. Do I just have a typo? Oh, not next. This is... Oh, this isn't an option. Whoops. Okay, my bad. Let R equal L dot next. For some reason I thought that was an option as well. Okay. So now we're back to this. If L dot is operator R, or... Wait, is that how it works in Go? Maybe this is saying do nothing. Is that right? I thought it would just match the next one. I should really stop closing this. Let's take a look. I don't have any fonts installed, obviously. Oh, so it just ignores it. What? I guess I should try Go Lang. Why are there pictures of... Oh. Why did I think it just fell through? Unclear. Okay. Does this do something? Oh, it does something. So basically this says just always call it? Okay. That's kind of weird. Yeah, if it is an operator, just do nothing. So I guess we'll just call this. And then this will be if. Why does this not work? L.next gives us a rune. Oh, it's the same thing again. My goodness. Next entered. Okay. Wow. That is kind of annoying, right? The lowercase next and the uppercase next. Yeah. Okay. I'm about to have to rename my next to like pub next or something. Just to really drive it home. Or, yeah, that's right. Okay. So, we're just always going to check this. Okay. That's fine. If let sum r equals this inline. We're going to call L.isOperator. And then if is alphanumeric r, L.next return the token for, what the heck? it's an option. Let's see, this is mute. Oh, I think you have to, this only works on, yeah, okay. Okay. This might be a loop, because then we can break with a value, right? Well, let's, yeah, let's just loop. We'll just loop. Loop. Because we're not going to use our, let's see, there's R. Oh. Yeah, that looks fine. Let R equal loop. So if it's alphanumeric to start, then let R equal L dot next enter. And this is what? An option. If let sum R and R is alphanumeric R, then we do nothing. Else break. Ooh, this is awful. 4 is alphanumeric R. So EOF is obviously not alphanumeric, right? Yeah. Okay. Why is this so confusing to me? I really didn't expect like booleans and loops to be the confusing part. So we're looping while, I think it's this option thing that's really confusing me. So we're looping, basically we're just looping while it is alphanumeric. But we have this extra step of checking if it's not EOF. So this is really just a strange while loop. So while it's sum and alphanumeric, go around again, continue, else break R. And that's actually fine. That works. Besides something else. This semicolon. Apparently it's still mad. Break. Oh, of course. There we go. Okay. So that basically gets us R out of the loop. Okay. So once we finish the loop, we can call L back up. If not L dot at terminator, then we're going to return L dot error F, bad character, else we let word equal L dot word. If not L dot defined word, return L dot error F. Word is not an operator. Let's put some quotes around it. Great. I think that's it. Was there a function here we needed? Oh, I need a semicolon. Not there. There. Whoops. Do I even have a make file in here? Is the only way to do this like that? Okay, that's fine. Cannot find is identifier. Let's generate that. And let's see. Is identifier. Oh, I think we missed something. Hold on. Operator. Lex operator. We finished the big switch, or actually this big if. If let's L.peak. Yeah, that's our switch on L.peak. Oh, hold on. Oh, this one. Okay, if word is this or this. Oh, did we do it? If is identifier L.word. Then we're supposed to return. Okay, I think we took care of that. Now we just need to look at is identifier. Yeah, this is why you should never write documentation, because it gets out of date, right? I guess we better call it S. Doesn't this mean that S itself, doesn't this mean S equals this? You check that the length is 1 and that the one element is this. Oh, I'm not going to be able to index this. Sense. True. Now we have to check some other stuff first. Oh, this is going to tell me to use first. Oh, what? Ah. Wow, Clippy is just so nice. So nice. I would never have used s.starts with. Now this makes it look a little less silly than this. Ah, I bet. Okay, so this really did used to be a slice, I bet. And that's why they wrote it like this. I bet we can do... Yeah, that's a good question. So, and I would say it's a little bit of a mix between... Sorry, you guys, if you can't see the question... never done such a rewrite? Do you just rewrite function by function, or do you get an overview of the whole package first? And yeah, like I said, I think it's a bit of a mix. It kind of depends. I think ideally you would get an overview of the whole package, because some things you may not even really need to rewrite, especially when you're going to a different language. Like you may be able to do something in a totally different way. But in this case, I'm kind of taking the naive approach where we just go down the file. We started out in main, and we go, let's look at main real quick. Oh, it's not called main. Yeah, we're just kind of going straight down main. So we did the context stuff, and now we're up to the scanner. So in this case, yeah, I'm pretty much going function by function, which is probably not the best approach, but it'll probably get the job done. I guess another thing to say is that it kind of gets me into the project, I think, to do this this function by function thing. So I'm kind of hoping that I'll get like a grasp for what's going on by doing this. Yeah, that's true too. Yeah, Go, I think it has been quite similar to Rust. So it might be a lot better for this approach. Yeah, definitely. That's good. That helps me justify what I'm doing a little bit better. Yeah, it's not. We don't need like such a global view of it because we really can. We can trust the implementation pretty well. Okay. I guess we want chars. Oh, it takes one. Oh. Unicode is digit. A decimal digit. Okay, so we're only checking for decimal digits. Yeah, so in situations like this, this is one of the few times I miss Perl. It'd be great to say return false if first, something like that. Just wrap these lines into one. I guess that's actually similar to like C or C++, right? Where you can say it first, return false, without all the braces and stuff. I guess we can do this in Rust, but I think the formatter will put it back. And what does it want to do? Is ASCII digit. Okay, great. If first. Okay. Else if r not equal to this and not r dot is. I guess we're gonna try alphabetic. Is a letter. Category L. I don't think that's exactly the same thing. But we'll hope it's the same. Okay, then we can also do is digit. I think we already took care of is alphanumeric, right? So is digit return we'll fix that variable in a second, and hopefully clippy will fix this for us as well. So we should get a couple hints here. Rename this to R like theirs. I guess it should be B in our case, probably. Or, yeah, B for byte, maybe. Yeah, why not? Whoa. It does say ASCII. Okay, what other to-dos do we have? Great. Okay, let's go ahead. We might skip the complex one for now, because I think it's quite complex. And we could just do the, well, I guess we want to do them all anyway, so we'll just go for it. What is this? I don't even remember this. We can go ahead and generate this, hopefully. Excellent. Oh, we might have to make this generic. Yeah, so we're looking for two numbers separated by a J, basically, I guess. L.error add complex number syntax. Otherwise, great. We just have to go do, oh, expected one argument. Oh, right. I think there's a way to do this, right? You know, I could borrow this. I think, can't you make your own functions that take format args or something? I'm not sure. That sounds familiar from the book, but can't remember. Okay, let's go look at accept number real quick. This looks kind of complicated. Scans a number, decimal, octal, hex, float. This isn't a perfect number scanner. For instance, it accepts dot. Oh boy. That's kind of weird. Alright. Optional leading sign. Oh, cool. So here's something else we've seen before. This exact comparison, right? Is it / or backslash? Is it a scanner or a reduction? So that could be a nice little helper. False. Oh, it's supposed to return tuple. False and l.init operator. Go away. Fly check. Shoo. Okay. We can't even see the bottom yet. That's a little scary. If we do make it to the bottom, we're going to return true, comma, any. Oh boy, what did I just import? The other thing I missed from Go is truly automatic imports. Obviously, the LSP helps a lot in Rust, but in Go, I mean, you can just write anything, and it'll just import it for you when you format. I guess Rust's module system is too complicated to do that totally automatically, but I definitely miss it. All right, let's go back up here. Okay, we got this. Might be a scanner or reduction. If it is, we take the next and then return. Otherwise, if r is not equal to a dot and not l dot is numeral of r, then we return what is lex operator. Oh. Wow, what is lex operator? It's lex operator. Okay. Okay, so we're inside this. If not L dot scan number true real part, return false. You know, we could probably wrap this the okay. What does it return? I think instead of returning this okay thing, we should just return a result. Or an option. Maybe an option. Something like that anyway. Return false, comma. Yeah, why are the booleans purple? Keyword face. What do they call it over here? Constant. Okay. Return false. So what I was just checking there is if this should really be ref stir. And it looks like it should actually be a string. Because we're calling toOwned inside. So we should probably just make the caller call that, right? Let's just make this a string. And then we can get rid of, we can just say argue. Great. So that helps us every time we're doing this with format. Get rid of that. Okay. So we can generate that function. If not, scan number. Do this. Okay. Now we're going to call peak again. If r not equal, whoops, return true, flex any. Are we going to use r again? It looks like we are going to use r again. No. Use r. Okay. Oops, not irrational. Back up. Oh, no, not pause. Minus 1. True. And Lex operator. It's kind of interesting to me that we do all of these, this backup stuff, right? It kind of seems like, well, yeah, I guess you have to backtrack sometimes. If real part. Okay, so Clippy's probably telling me, yeah, that's nice. Oh. Why is it way over there? Okay. Okay. Yeah, I don't think this would help. I wish these were links. Really wish these were links. I have a bad feeling that all of these should be char instead of U8. I think everywhere I used bytes, I should have just used chars. Yeah. So, we're probably going to have to fix that at some point. But what can you do? Okay, so I think we handled everything for accept number. Let's look for our next to do. Scan number. Following, oh my, following slash okay. Following slash okay. Following J okay. This returns another bool. Is there documentation? No. Okay. Whoops. What the heck? Why do they do this? I don't know. I just don't understand. Does this get, oh, digits of base equals D? Oh, it's like a cache. Digits of base equals, so we can just look it up later. We're going to skip that for now. Definitely. Okay, so we got these. Base is less than or equal to 10. Then we just return decimal. Actually, depending on how these are used, this is probably not what we want to do here. How do these get used? What does accept run take? A valid. What does valid set? Yeah, we probably don't actually want these to be strings. We can just return decimal up to 10. Can I not slice this? Oh. Yep. Oh, wow. So we have to concatenate them. Alright, let's just make it a string. Because we actually can do the plus concatenation on a string, but the L value has to be a string, I think, or the left hand of the plus sign. This might work. Oh, just need to borrow. And this needs to be string from. Okay, there we go. I'm not going to mess with the caching. So that's digits for base. So we can go back up here, let digits be digits for base. If base 0, is that the default? Let's look at our config. Base. Yeah, the default, yep, perfect. Oh, typo. Time for a PR. That's fine, it's just complaining about the return value. I might just need to alias self to L so I can just allow the L stuff. So this is, we're looking for floating point numbers right now. So we take as many digits as we can. If we find a period, we accept more digits. If we find a scientific notation thing, we accept that with an optional sign, plus or minus, accept run. I see that I'm using L instead of self again. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's kind of interesting. Shouldn't this accept bases digits? So even if you have, I mean, sure, I think it would be weird to put in a, what's wrong here? Yeah, sure. I think it would be weird to type in a hex floating point number with scientific notation. But everywhere else we're using digits. Yeah. I mean, it would definitely be weird, right? But, yeah. This takes valid string. Now this one I think does not need to be a string. I think this one can be a str. Yeah. So if it doesn't change, if it doesn't break, okay, great. We have an unclosed delimiter. Yeah. Okay, except run. Oh, that's the unclosed thing. Except run. Digits. Okay, now we just do this. Yeah, because except run. This doesn't need to be a string. It can just be this. Digits, digits, except run. Okay. Now we're going to peek. Oh, yeah, and everywhere we have an R should probably be a B because R is for rune, whereas we're using bytes, so B should be bytes. Eventually it should be C because we should probably switch to chars like I said earlier. What a mess. If following / OK and R equals B, we return true. If following J OK and R is J, return true. Okay. We can probably collapse these together, right? What's wrong? Okay, I know. Next thing mustn't be alphanumeric, except possibly an O for outer product or complex. So this is still, we're still using R here. If R not equal O and is alphanumeric R. Next, return false. If R is dot or not L dot, not self dot at terminator, L dot next, return false. Otherwise, true. Self. Okay, let's check that out. This if statement can be collapsed. Excellent. Check again. Oh. Oh, right. There is no matching delimiter. Look at that. Oh, I remember. Right. Right. Okay, great. We made Clippy happy. Let's go back down here. Yeah, I realized later on yesterday that I did not need to make these functions. I mean, so we could inline fall through 2 right here, and then we could inline fall through wherever it's actually called. But it doesn't really hurt to break them up, I guess, either. Okay, are we done with complex? I can't remember. I think so. Yeah, accept number, scan number. Accept number, we called scan number. Did we write scan number? We did. Okay, I think that's it then. Let's look for more to-dos. Oops. To-do. Alright. Let's go down a bit. Check my phone real quick. Alright. We are looking for Lex quote. Looks pretty simple. The next. Okay. Scan a quoted string. The next character is the quote. Let quote equal. So it is L this time. L.next. Loop. What does this give us? This is supposed to be next enter, which gives us an option. So we should do while let some. Actually, I guess we will loop. Okay. Loop. So we'll do a let else here, because we're going to return. Let R be some. I messed it up again. Next enter. Else return L.errorf unterminated quoted string. Great. But after that else, we have R bound. So now we can switch on R. If we get a backslash, we call L.next enter. If let some. Wow, I messed it up again. How do I do that every time? So it's sum, and so our sum already checks that it's not EOF, and R not equal new line break. Otherwise we fall through. But we don't fall through to this case, we fall through to this case. That's pretty goofy. Okay. If it's a backslash, then... Wow, that was weird. R, because we checked here that R is not... Oh, okay, no, we do fall through here. Because we would break, if it's not this or this, we would break. So it could be either of these. Why did we even do this match? Get rid of the match. Get rid of this case. So we have an R. We got something from next inner. It's not EOF because we know it's sum. It's not if it's not new line. And it is equal to this, will break. Otherwise, else if case quote else if R is quote, then we'll return L.emit types. Oh, and here, this says break. Break? What does this break from? Break. Oh, it breaks out of the switch. Oh, this should be continue. This should be capital. And this should be return L.errorf. Unterminated quote string. Wait, but we already returned that once. Lex quote. Wait, why do we have this up here? Oh, right. Oh, wait. Oh, this is stupid. So if let sum R is this, what is R here? UA. I think this is just an else, right? So if let doesn't bind, why are there two semicolons? It doesn't even, rustfump doesn't even get rid of the second semicolon. I think this is just else, actually. And I can get rid of this. I think that's right. Oh. Gotta find R. Oh, that was the R. Okay, well, this is fine. Okay, that makes way more sense. I was thinking that this R... Okay, so this is actually a nice thing you can probably see from the LSP, is that it highlights these R's. Whereas if I click this, I can see now that these are the R's. And actually, I'm supposed to be switching on inside the loop, L.next, loop R. Yeah, that's right. Okay, it should be on this one. It's only this. Yeah, only in this case am I looking at this R. Yeah, only on this case am I looking at this R. Otherwise, I am supposed to be looking at this R. So that's all right. Okay, great. Yeah, this looks kind of frighteningly like an infinite loop, a potential infinite loop. But I guess because we're guarding, if we ever get none, that means we hit EOF. So we can only loop infinitely as long as the file keeps going on. So if we have an infinitely long file, we can loop infinitely, but that seems a little unlikely. Okay. Now raw quote should be the same thing, except with just a different quote character, right? Oh, okay. Here we do accept a new line. So these are like multi-line string literals, just like in Go. Okay. Why is my completion not working? Am I missing something? It never actually loops. Oh, whoops. So I actually need to unfuse this. There we go. So now it should actually loop, right? Great. So that's Lex Raw Quote. I think we're done with scan. Whoops. Scan.go. You guys definitely won't be able to see this. 3, 4. 1, 2, 3, 4. Oh, we won't have all the same functions, but we should have. Yeah, okay, this is silly. Never, forget it. Forget it. Okay. Do we have any to-dos left? Doesn't look like it. Oh. Let's see if Clippy is still happy. Okay. How long have we been going? An hour and a half. Yeah, well, I said probably a short stream today. Yeah, looks like we finished scan. Okay. Let's go over to our README. Scan.go. Great, we finished a big one. So let's see. We're up to 8.19% completed of our translation. And let's go back to ib.go. So I think we set up our scanner. We made scan new. save file. Make recipe. Progress and readme. Finish scan/scan.go. Great. The other thing I want to do, oh right, is go back to our main. Go back to Ivy. New. This is probably private, isn't it? Pub. Clippy. Great. What does it take? It takes a context. How do I get a context? Oh. How do I get a context? Let's see if we can get a default context. Wait, but it does have default. What? Okay. I guess we have to have a new then. New. Yeah, okay, new from a config. Okay, great. Back to main. Let context equal context new from our config. And then we'll make a new scanner that takes a context. It takes a name. And it takes a reader. Does this have to be a string? We can just do this. Okay, great. Parser, new parser. And then we call run.run parser context true. Okay, pretty cool. We can almost use this thing. I guess parse.go is up next. 700 more lines. New parser. Ivy parse. It's supposed to be a reference to a scanner. Oh, well, it did that for me. What's the problem here? And, okay. R is read. Pub. Scanner. Yeah, so I was about ready to call it quits after the scan thing, but it'll be nice to just get this going for tomorrow. Scanner. Tokens, and do back of token. Token buff. Not a vector. It's going to be a token I always put these in the wrong order. Let's see. I think I got it right this time. File name string line usize, not use size, and it takes a context. Doesn't the scanner has a context? Why does it take its own reference to a context? Surely it can't be a different context. Let's just write that down, just to think about later. They're casting it as an exec.context. What? Weird. I don't know about all this. Oh, it takes a value context and casts it. This takes a value context. Oh. What? But I think we use the same context everywhere. I don't know. We'll leave it for this for now. If it causes us trouble, we'll rethink it. Oh, look, they could save space if they just reordered the fields. Another PR. Okay. Generate new. So, we do take a scanner. We take a file name. This is the top. File name, scanner, and a context. We don't take this. Tokens, back, new. This is going to be token default new 100. Does this one have a default? Probably not. Oh, it's not copy. Can it be a copy? I don't think so. Yep, I didn't think so. How does this work? Now, why doesn't this work? Expected array. What? Token default. Oh, duh. What's the problem? 3 generic arguments. Oh, come on. Why can't it figure some of them out? Core array. Maybe I have to just call it. If I have to take 1 argument, but it takes 0 arguments. Oh. To actually call it. Okay, line num is going to start at 0. 3 generic arguments, T and F. So the type is obviously token. shouldn't have to write that, that's for sure. Oh, okay, there we go. There we go. Oh, that's pretty cool, actually. That's better, because what I was about to do was make it like maybe on a knit. But we don't really want to do that. Okay, we got parser new. And then we're going to have run.run. Run runs the parser evaluator until EOF or error. And this is in run. Okay. So what should we say here? What did we do over here? Great. So that's parse. Let's go back to lib for a second. We can do pub mod run. And we'll also start run. Takes a p, which is a ref parser. Takes a context, which is a context. Again, we only have the concrete implementation. We don't have the value.context interface. And then interactive is a bool. And it returns a bool. And we'll go ahead and put to do in there. Runs the parser evaluator until EOF or error. The return value says whether we completed without error. So clearly this should be a result. Whoops. Okay. This returns a result. Use a custom error type instead. Oh. I'm going back to my bool. Clippy never complained at me about the bool. Why did I type Clippy? I'm so mad I can't think straight. Okay, there we go. The return value says whether we completed without error. If the error value is true, it means we ran out of data, and the run was successful. Typical execution is therefore to loop calling run until it succeeds. Alright, fine. I guess this has to be pub as well. Why does it allow me to return unit T but not unit E? Great. Go back to lib. Actually, go back to main. It's actually like while not let. What do they call it? Success. Okay. Actually, maybe we just do while run. Did I make it pub? Run. I did. Okay. While run. Oh, we don't have a. File name. Student. Scanner. Context. I guess this needs to be a reference as well. And content, I was going to say I moved it here. Scanner. Oh yeah, this thing. I talked about that very briefly earlier on, but this is from LSP mode. It's called, they call it like a breadcrumb, I think. LSP mode, breadcrumb, yeah. And it's kind of, it seems like a minor thing, but it's actually kind of cool. It helps me stay like oriented when I'm way down in a directory tree or something. And it is one of the things I miss in eglot when I've tried it out. New parser. Let's go look at this. This takes a context. I shouldn't. Oh, I should. Let's see. I don't know if I can find the link, but I was looking for this earlier, and some people were talking about how to do this in eglot. And there's this package called. Let me turn the breadcrumb off again. It's called which function mode, and I guess I have too many modes going on here. Oh wait, let me turn off my recording for a second. So you'll see here. This which function mode does something similar, but in the mode line. Actually, do I still have this in my Scratch? I must have closed Emacs earlier. But you can basically, if you look into which function, it uses imenu to gather this stuff. So you can like concatenate the stuff from imenu. Concatenate stuff from imenu, but then you have to also use stuff from like projectile or project el to get the directory and file name. So yeah, I was looking into this pretty heavily earlier because I would like to switch back to eglot, and I want to start playing with Tree Sitter too, like you said, since they both just got merged into the master branch of Emacs. But if you make any progress on that, let me know, because I'll just use what you have. Right now, I'm just trying to figure out, where do we use this context? I think maybe this should be a reference as well. Because we can give out multiple shared, or we can give out multiple immutable references. Let's go take a quick look at our scanner. And maybe we can make this that. Then we can borrow this, and then everything should be okay. We'll see if Clippy's satisfied. Context. So now this just needs to be borrowed. Should be no problem, maybe. Oh. Parser. Okay, great. And now we can actually call this like we wanted. While run parser context true. While not. Now let's import it. Oh. Oh, everything's wrong. Expected. Okay, we just have to borrow. Oh, while run dot is air. Borrow later used here. This is so crazy. Oh, okay. Okay, so that is the basic outline of our main. All we need to do, we need to actually implement run, which means we need to actually implement parser, and then we'll be good to go. So it looks like if we hop into this new parser, so we've got 600 lines here, and if we go back to run, we've got 200 lines here, but then we're going to have to actually do the evaling. And I don't think we have written the eval stuff yet. We certainly haven't written all of the operators, which I think we can see. Yeah, binary. This is kind of like the main thing when we actually evaluate stuff. So this file will be huge eventually, which I think we can also see in our README. Yeah, binary is the largest file, followed by unary, followed by matrix, which we haven't even started looking at yet. So, okay, great. So we're in a really good place for tomorrow. Let's see, context. Okay, let's try to make some more reasonable commit messages. Okay, so the first thing we're going to say is we added a run module. We'll just call it run. We gotta fix that. Okay. Yeah, we just had to mess with that. And then let's check Clippy one more time. Excellent. I mean, I guess we can actually cargo run this now. And we get an infinite loop. Fantastic. Actually, can we do anything? Okay, great. It doesn't do anything at all. That makes sense. We can type at it at least. Yeah. But anyway, I think I'm going to go ahead, push this stuff off. Unpushed. Let's try real quick. What CPO? Let's see if we can take out any of our allow unused stuff. Okay, can't take that one out. Ooh, maybe we can... Oh, whoops. Let's just make this full screen for a second. Okay, we can take that one out. How about this one? We still don't use push. We still don't use pop. We still don't use no op. we still don't use variable. Let's try this one. We do use a config. Oh. But only the input base. Okay. How about scan? Do we use this? It looks like we use this. And we actually do make a scanner now. We don't use the name. Okay. Leave that for now. We use new. Excellent. We can take that one out. We do use backup. We do use emit. We use accept. We use accept run. I think we use next. We use numeral. Oh. Why did I have two of those? We use this. I think we use this. Define. Yep. Use that. We use that. We use that. And we use that. We use that. I guess we actually use everything in. Oh, we don't use that? But we use this here, right? Okay. We use this. Looks like it. And we use this. Do we use the parser? Kinda. Alright. Let's see if Clippy's still happy. Yeah, I don't know why the formatter didn't take care of that. Unused variable. Okay, now that's something we should probably look. We should check that. Were we supposed to use that? Oh. And we can borrow that. Okay, that's great. So that was very helpful, Clippy. Great. Okay. Remove some allow unused annotations. Well, I guess I'm having fun. I can't really... I keep saying I'm going to end the stream, but maybe we'll just keep going. I'm kind of waiting for my wife to get off of work. So, okay, let's go back to main for a second. And we'll just go into run. I'm sure... yeah. I'm sure this will bring us back to the other stuff. Okay, so conf.output writer. So we do actually use the writer here. We might have to add this back to our config. We'll see. I'm just going to call this W. Yeah, this was config. Let's go look at this again, because I've been thinking about this, and I think I was doing something dumb. I think it's actually possible to include this here. Yeah, I think the issue I was running into was when I was trying to do that hash map that needed to know about the the reader and the output in the error stream. So I think we can add this back in. So O, E, these have to be both right. Okay. And output is supposed to be O and error. Maybe we'll just call it error. Okay. And when we go down to new config, didn't hit tab on that one. We can do this for any config. Well, let's see how this propagates. Missing generics. Okay, now context has this. So O, E. So we have to have this on parser. Okay, so now impl O, E. O is right, E is right. I think I just used the wrong right, but we'll see. This might not be so bad. I think I'm using the wrong right. Okay, scanner, OE. Seems fine. Two generics. OE. Missing generics. Okay. Hopefully this will work. E. It's gonna be really sad actually if this E is also right. We're gonna find out pretty soon. Okay, I need to import that. Can I just do this? I probably could have just done that everywhere, right? But it's okay. Does that work? Oh, we're still not done. Missing generic. Oh my goodness. This is brutal. Okay, let's keep going. 3 generic arguments. Override it. And the reason, I mean, it's probably obvious to most of you, but if not, the reason we're defining 2 separate generic arguments is because standard out and standard error, at least in Rust, and I think in Go as well. Okay, maybe not in Go. But in Rust, standard out and standard error are different types. So if I were to define this with just W, for example, both my output and error streams would have to be, they would either both have to be standard out or both have to be standard error. So we have to define 2 separate generics for the 2 things. E. Now the one thing I do wish we could do is say that O and E are both right. Like have the 2 things, but say they're both. Now this, of course, really makes me want to inline these. I'm a bit curious why is Lex, but run is called, so why does it say that any is never used? Why is fall through not used when it's used here? That was a little weird. Well, maybe it, okay, maybe it is used. Maybe it's just like a typo kind of thing. Or it might actually, now it might actually be upset. Oh, wow. Yeah, we really haven't done anything in reduce. Now there might still be a better way to do this that I'm not considering. Let's see, generics. AOE. Do the same. How many errors? Oh, we're down to 3 errors. This is great. We're getting there. I wonder if I can leave off the lifetime. Yeah, I think we can leave out the lifetime here because, oh no. Oh boy, unconstrained type parameter. It's not constrained. The type, unconstrained type parameter. Oh no. By the infiltrate, self-type, or predicates. So I think we might have to make function itself generic. over this. Or we should just make eval unary. Let's go back. Okay, I'm kind of confused now. Oh, I think this is supposed to go down here, right? This does have C-tick. And this does not have C-tick. Okay, is that what the problem was? Yes. Okay. So this part is supposed to go down here. Okay. That looks okay. I just put these in the wrong place. Oh, no. Okay. For an expression, I think now this we do have to put here. Missing lifetime. Does this need to be tick A? Yes. It takes 2 generic arguments. Oh no. Yeah, wait, that's what it wanted. Tick A. Okay, with the expression, construct function, OE. Okay, still looks okay. OE. Okay. We're looking alright. Oh, I'm so scared. This is the annoying thing with, you know, like the lifetimes and the generics, is that the number of errors like contracts, and then when you take care of all of those errors, sometimes you get like much worse errors. I've run into this a few times before. Do we know what these are? And it's always very sad. And this feels a bit like that. Which is why we started this with like a clean Git branch, I think. Because if it doesn't work, I'm just gonna destroy everything. We're just gonna... Yeah, actually, if that happens for sure, I'm going to delete the unstaged changes, and I'm going to call it a day. Okay, now we see what O is right and E is right. Oh. Oh. Why can't these just inherit here? Maybe this should be OE. We'll just make the trait generic as well. How's that? This is a bit of a nightmare. It's starting to look like maybe we should have okay, so this is supposed to come out and go in here. I got one of these. Unary op is supposed to take, actually, propagate around those. Let's put this here. Actually, we need to put it over here, and then we put tick A, O, E. Okay, so now binary op can't be made into an object because we have it on here. Binary op itself needs to be have this on it. Okay, box in OE. OE. This looks fine. It's looking okay so far, I think. Tick A, OE. The trait right, oh, font right. Is not implemented for scanner. I think I imported the wrong right over here. Yeah, it needs to be IO right everywhere. This method is not compatible with the trait because there's a lifetime mismatch. Info, binary op, lifetime mismatch. Context needs to be tick A. Method not compatible with trait, probably for the same reason. Yep. Tick A. I wondered why I didn't have to put that before, right? Lib output. I guess it returns a reference to. Can I do that? Probably not, right? Expected. Oh. Okay. Yeah. Now we're going to get into the tricky ones. Lifetime may not live long enough. We're going to have to actually think about lifetimes. So tick A is defined here for the context. Pub fn eval unary. Let's call the lifetime of this reference tick 1. Okay, so when we're in eval unary, I better make this full screen. Okay. Well, sure. We can get rid of this one. All right. We're inside eval unary, which is inside context. So the lifetime of our context is tick 1. We call self.unary, which requires tick a self oh my. Requires that one must outlive A. Eval. Wait. Okay, hold on. Wait a minute. Yeah, wait, but this lifetime, tick a self. Eval, so this is tick 1. Tick 1 must outlive tick A. Yeah, isn't that obvious? Oh, okay, there we go. Yes, we just have to say that this one is also, the self is also tick A. Okay. Oh, oh no. No, all of our dead code came back. Oh, it's because, hold on, let's go back to main. Run. It's because I have a to-do somewhere. Is that right? To-do. We're hitting a to-do, I think. Wow, I can't believe we figured out that lifetime stuff. Oh, very exciting. This is definitely the most complicated Rust code I've ever written. So that's great. That's an excellent reason to have done the project. Right? We're doing stuff that I don't usually do in my scientific code. So great. That's exciting. We got some pretty complicated lifetime and generic stuff to work, I think. I'm happy about that. Great. And we got to preserve this output stuff. Okay, let's clean up this stuff again. Actually, hold on. Okay. Restore output and error fields on context? Or is it config? Config. Okay, so now that we did that, we can try to do, actually, how does Clippy do this? Oh, it deletes it. Okay, no, we're not going to run Clippy fix. Okay. Should probably use a macro for this, but we'll just go for it. Whoops. Oh. Alright. I guess we should have done it one at a time, huh? Let's see. Because some of these, they like depend on each other. So if we mark one of them, okay. Yeah, there we go. Okay. Clippy happy on dead code again. Okay. Alright, now that generic stuff did kind of take it out of me, so I think we will leave it there for today, actually. Yeah. Okay, well, thank you all for joining me again. As I mentioned, tomorrow we'll jump straight into run. We'll start playing with all of this stuff. So this is what we're... Oh. Okay, hold on. One last thing before I go. I was very worried we were going to hit this because if you look at the definition of error F, right? Oh. Yeah. Is it this one? No, I think I'm looking for a different error F. Maybe it is this. Yeah, value error F. It panics, right? We go into error F, it just panics. And so now in run, although this is the defer function, this might be okay. Return. Okay, no, maybe all it does is return. But I was afraid basically that we were using panics as like control flow. Right, like you panic down in error F, and then up here in the run function, you just catch the error with recover, and then you go back to work. But it doesn't look like that's the case. I think these are like real panics. Yeah, cool. But yeah, so we'll pick up here tomorrow. I'm assuming that this basically will dispatch us through the rest of the code. So like when we go through run, somewhere in here, we're going to call the eval stuff that we haven't implemented yet. Context eval expressions. Yeah. Okay, so we'll probably end up back in context. We'll have to actually work on eval. And eventually we'll start adding some operators. So that'll be great. Anyway, thanks again for watching, and I will see you all next time.